Actually, let's look at this question, which was taken from the year 2008, paper 2, question 7. I believe this question is modified, right, and taken from one of the school tutorials. Yes, you can do this proficiently. So a computer game simulates a tennis match between the two players, A and B. Each set is won by either A or B. So essentially, there's no draw. It's either you won by A or by B, right? So the simulations are used the following rules. The probability that A wins the first set is 60%. For each of the set after the first, the conditional probability that A wins the set, given that A won the preceding set, is 70%. And for each of the set after the first, the conditional probability of B wins the first that set, given that B won the preceding set, is 80%. Okay, great. Now, I think the main thing is to draw a tree diagram first, then try and understand what's going on. So this is a tree diagram here. A won the first set is 60%. So this will be 60% here. Okay. Then after which we told that for each of the after the condition that A wins the subsequent set, given that A won the preceding set. So when he won here, this will be 0.7. Okay. Then after which if B won the first set, right? The preceding set won the preceding set, then he would have won. This is 80% here. Okay. Then from this tree diagram must be able to interpret it. You have A part 1, which is you want to find A wins the second set. So meaning to say, we want to find A win the second set, which is this guy here. Okay, so if I were to fill up all the missing branches here, this will be 0.4, then this is 0.3, 0.2. Okay, you could get the answer there. We just need to add these two branch out, so it's 0.6 multiplied by 0.7 here, and add this up. Okay, so it's 50% of the time. So then for part B, you want A wins the match. So in one variation of game, right, a match consists of at most three sets of game. So meaning you could just branch it out. Then the match is won by the player who first win 2 sets, right? Calculate the probability that A wins the match, the entire match. So this will mean that you already won, right? You already won the match here. So there's the third match here. So I'm going to extend this branch here. Extend this guy. Okay. This one would mean that B already won because B already won. So you don't need to extend. So what you need to extend is just these two guys here. Then we need to add up this branch here. A win two sets and A win 2 sets here. Okay. So that's that. So we know that if B won this match here, so B will have an 80% chance of winning. Then this is 0.2. Then same thing, A won here, there will be 70% chance of winning here. Okay, then this is 0.3. So from the tree diagram, I think it's quite straightforward. We need this is when A win. If A win 2 matches straight, you just automatically win the match, right? So 0.6 multiplied by 0.7. Then I add this branch here where he won twice, so there will be 0.6 multiplied by 0.3 multiplied by 0.2. Then this guy, I will add it up. This will be 0.4 multiplied by 0.2 multiplied by 0.7. Okay, so that's that. So the answer is 0.512. So the part 3 should be quite okay. B wins the first set given that A wins the match, right? So I think the A win the match we already found. So this is a conditional probability. If you are struggling with conditional probability, always consider the denominator. Okay. So the cases where A wins the first match are these 3 cases here. 1, 2, 3. No, A wins the match. Sorry, A wins the match will be these 3 cases here. I use a subscript to indicate the match which they won. So these are the cases we have. Then you ask yourself, which of all these cases here, which are the one that B wins the first match? Okay, it's very clear. This is the only case where B won the first match. So this is P, B1, A2, A3. Okay, so we're just gonna do the same thing as what we did just now. So 0.6 multiplied by 0.7 plus 0.6 multiplied by 0.3 multiplied by 0.2 plus 0.4 multiplied by 0.2 multiplied by 0.7. Then you just put the top there. Okay, multiply and divide. This should be your answer. So the answer is 7 out of 64. There you go. So let's look at the last one. In another variation of this game, there's no limit to the number of sets, and a match is won only when a player wins 2 consecutive sets, right? So it means this goes forever. Show that the probability that A wins a match is 119 over 235. Okay, we're just gonna draw the tree diagram out because this will be gonna be slightly complicated. So if you were to draw the tree diagram, you realize that actually the game will stop after AA or BB. Okay, because 2 consecutive games they will win, right? So you're gonna stop the tree diagram here. But the problem is that because the probability that you start is different, 0.64 is conditional, so this is 0.4. Okay, actually only the start is different. Subsequently it's not, right? So this is 0.7, then this will be 0.3. Okay, now once you hit B, okay, this is 0. Then after which this is 0.2. So obviously you don't need to worry about this because this is where B is winning. You need to calculate the probability that A is winning. So this is 0.7 A, then this is B, right? So you will stop here. This is 0.3. You realize that once you hit 0.3, this cascading tree diagram will start from this B here. This B is the same branch because what we need is actually B. Then subsequently, we need to know what is the probability of A winning. Okay, so I'm going to draw the diagram where if say you have a B here, which is like B wins this match here 0.3. Okay, what would the probability of A winning after B winning? Okay, that just sift this out. So you need this one and this one because this branch here and whatever branch behind here will be the equal branch. Okay, understand that? Essentially what I'm saying is that after this branch here, these are 2 equal branches, so I need to calculate what is the probability that A winning after this branch. Okay, then we can just replace it where entire thing as A wins. So this is tree diagram here. You know that after B wins, A have a chance of 0.2 winning, but you don't need to calculate the BB here because this will B will win here, so we don't need this branch here, right? But what we need here is that once A wins, this is 0.7 chance of winning, 0.3, then this is B winning would be 0.2, and then 0.8. Okay, but you don't need this 0.8 here, same thing, 0.7, 0.3, then you just keep going on forever. This is 0.2, 0.8. So after this branch, I just want to calculate what is the chances that A wins. Okay, from here onwards. So same thing, A wins. Okay, remember, if you have not done any cascading tree with practice, please do the easier question. This is not a direct easier question, right? So this is what I'm gonna write. Okay, so the probability of A win after B win will be this guy here. So this is this. Then I'm gonna get this guy here, sum this up and sum this up also. So this branch will be 0.2 times 0.7. Then this will be 0.2 square because there are 2 square here. Okay, and then so this will be 0.2 square. 0.3 multiplied by 0.7. Move on. This branch here. Okay, so this is what we get. You realize this is a GP. So this GP here, the first term is this guy, and this is A. Then the R will be multiplied by 0.2 multiplied by 0.3 here. Okay, so that will be our GP there. So it's A 0.2 multiplied by 0.7, 1 minus 0.2 multiplied by 0.3. Okay, that's that. So the probability A wins after B wins, it will be 7 over 4. In fact, I could also replace this entire thing with this guy here after. Okay, so the tree diagram would be this. So this guy, you could the tree diagram here, the first one could be reduced to this guy. It's just gonna be A wins after that. It is infinite series. I'm gonna put 7 over 4 here, 7 over 47 here. Okay, so to find, we need to do that because this guy, the first one is 60%. That's the messed up part, right? So we just need to sum this up. So I'm gonna add all the branches up. 0.6 multiplied by 0.7, which is this guy here. Then 0.6 multiplied by 0.3 multiplied by 7 over 4, 7. Then the last one, which is this branch here, this guy. Sum them up. Okay, so shown. That's how I do this question proficiently. If you have any questions at all, please do let us know and I'll see you in the next question.